So good morning, dear all. Thank you very much for attending our lecture on applications of data science for software engineering. It's a great pleasure for me to introduce our speaker for today, Dr. Damian Tamburri from Jeroenimos Academy of Data Science and our own Eindhoven University of Technology. Damian is an expert on qualitative methods. And specifically on applications and qualitative methods to empirical software engineering research, which will be complementary to predominantly quantitative kind of techniques we've been discussing so far. So without further ado, Damian, the stage is yours.
Yeah, thanks a lot, Alex. So as a matter of fact, I chose not only the level of detail, but also the introduction to the topic of qualitative methods in empirical software engineering research on purpose for the kind of data science angle that you have. Now, as it turns out, data science is part of the name on the institution, on the billboard for the JADS, or Jeroenimos Academy of Data Science. Now, also what I brought indoor is, as Alex was saying, a bit of qualitative flavor. Now, it's a good thing to play around with numbers. It's a good thing to, apply lots of machine learning left and right and all sorts of advanced artificial intelligence. But, however, around that, there is so much qualitative research that oftentimes is very much unstructured, which is becoming a big problem, right? So that's also what I've been trying to fix in JADS gradually and steadily for the past 3 to 4 years. Now, I was born into this domain working mainly in data-intensive computing. Now, data-intensive computing is essentially all sorts of computing, all sorts of advanced, more or less advanced software architectures that have to do with a lot of data, big data. Here's a nice metaphor to phrase the huge diversity of this ecosystem, which is not mine. I didn't design these slides myself. They're courtesy of O'Reilly. So if you go and take a look at the data-intensive computing book by Nathan Martz, you will see these islands coming up left and right, and there's a lot, right? So there's all sorts of island spots in terms of uncharted data-intensive territories or data integration issues, the realm of data flow, or what have you. And there's more, right? So there's plenty of them. There's all sorts of analytics islands, which have to do with time-resolved properties and materialized views and dynamic views and things like that. And what is more, beyond that, you also have things like data types, right? So documents or key value or column or the relational empires or relational databases as opposed to columnar databases and so on and so forth. And this is not it only. These are just the islands that represent the components. How about the islands that actually represent the path across these components, right? So what are known as data-intensive architectures. How do you move from one component to another? How does the data migrate from one component to another? And how does that manifest value into reality? Now, what you are seeing here, this path is called the Lambda architecture. Pretty much all of the current data-intensive architectures, I would say about 70 to 80%, are rested on these sorts of architectures. But what if I told you that a great deal of what is happening before, after, and during the building and fine-tuning of these data-intensive architectures, qualitative research is responsible for a major component of the qualities of those architectures. And I will show you if and how and why. And by the way, in case you are really wondering, you shouldn't listen to me. I mean, maybe you should, or based on experience, I understand if you are perplexed. But keep in mind, all of the algorithms that you have in the realm of data science, and to some extent also the realm of data engineering, big data engineering, are essentially reducible to these sorts of classes of algorithms. as a matter of fact, 57% of the algorithms that you will find in industry belong to the first three classes on the left-hand side, and a mere 8% belongs to, the reinforcement learning realm, which is a bit towards the left side. However, all of these algorithms have several common practices, characteristics, design principles, but they will all amount to empirical experimentation, which rests on a single assumption. The assumption is you, as a scientist or as an engineer, are capable of capturing a domain, understanding the key features of that domain, and preparing a solution for that domain, for that problem, in a way which is appraisable and accountable. And this accounting exercise can be measured somehow in a manifested and provable way. How do you do this? And what the hell does all this introduction have to do with qualitative research? How do you do this? Is by using qualitative research. There's no other method that will yield the type of information that you need to actually proceed with a straightforward and sound data scientific endeavor, and also the deployment of whatever that endeavor leads to, unless you are capable and skilled in the ways, in the gospel of qualitative research. Now, here's a quick straight poll. I think I partially given you the answer already. What the hell does all of this have to do with qualitative research? Is it A, designing qualitative studies helps data-intensive computing, or is it B, qualitative data analysis is a prerequisite for data-intensive computing? Or is it C, everything starts from qualitative? One of my favorite authors, Robert Glass, would answer C because he's a good guy, but yeah. Or maybe it's D, it's just me. Yeah, I'm coming from data-intensive computing, so come on, it's just an introduction. It's just my topic off the bat. So let's do a poll right here. Start a poll. There you go. A, B, C, D. Come on. Give me your best shot. Come on. You have 3 minutes. Actually, you have 3 seconds. There's not a lot of time. Actually, we do have a lot of time. It's like we have 90 minutes, do we? Okay. Okay, let's see. I hear a lot of B's out there. Okay, so can you guys see the results? I don't remember if you guys can see the results, because I can share them to you. Public chat, let me see. We have, yes, thanks, Alex. Oh, you cannot see the results. I can show you. Hold on. How can I show the results? I can share my screen. Let me take a picture of this. Aha. There. How's that? 70% is B. Qualitative data analysis is a prerequisite for DIC, data-intensive computing. Okay. So let's go to the answer. The answer, remarkably, is the top 3. Or ABC. Definitely, qualitative data analysis is a prerequisite for data-intensive computing, but it is also what comes afterwards, and I'll show you how and why in a second. Especially in the realm of data-intensive computing, everything starts from qualitative research. Qualitative research means you have a structured way to explore an unknown domain. And the purpose of that exploration is for understanding. Qualitative research is designed to go in depth as opposed to in width. And let's also contextualize that into data mining, or the typical model to structure data scientific endeavors from a high level. Now, what you're seeing here, in case you're not familiar with it, which I hope you are. This is the cross industry standard process for data mining. It's coming from IBM, but it was agreed into a standard by as many as 150 companies all over the world. It has been a thing for like 20 years, so it's not something I'm bringing in. Although the process is really straightforward, and go figure, these phases right here have very little to do with engineering and a lot to do with qualitative empirical software engineering. Let me give you a stupid example. Business understanding involves domain modeling. It involves domain exploration. How do you explore a domain because you don't know anything about it? The how comes from qualitative research. You can instrument an ethnographical, ethnomethodological study in which you yourself, the analyst, embed into the domain. You take daily or hourly notes on what is happening in that domain, and then you analyze all of this material to figure out features, characteristics, variants, stakeholders, actors, roles, responsibilities, anything that can be used to describe the business and whatever understanding you have over that business. The better you do, the better you get at this, the better your business understanding will lead to an exact problem formulation for you to address. And remember, data science, as you probably have figured out by this time, data science means garbage in, garbage out. So if your business understanding sucks, then your data scientific model will be equally worthless. Now, suppose you actually endure the data understanding, data preparation, and modeling back and forth exercise. What if you go back to the evaluation? How do you evaluate a model? A model is only as good as the business intelligence it is supposed to bring about. Unless you can find a way to exactly prove to your stakeholders that your model is worthwhile, you will have wasted a lot of time and probably money. Now, the only way in which you can actually bring about this understanding is for you to know, to understand, to figure out what are the evaluation metrics, the factors, the stakeholders, the actors, and the variants that you need to address and evaluate. There's a good chance somebody will tell you, because this qualitative understanding maybe is already present, maybe it's part of the organizational culture, maybe it's part of the problem definition, but it's a safe bet that in the rest of your career, you will be faced with this issue over and over again. So you better start thinking qualitative, big time. Last but not least, I'm a big data architect and big fan of data-intensive computing, as you might have figured out at this point. Deployment of machine learning models has everything to do about figuring out the right ways to do deployment, the optimization of the cost variance, and understanding these dimensions forces you to conduct qualitative research. Now, we have talked about qualitative research. So I understand your faces. I know you are perplexed. And I know you might be still wondering, what does all of this have to do with data-intensive computing? Don't worry. We are going more and more into the actual core subject of this session. So I want to guide you through the design from a high-level perspective of qualitative studies, and also some techniques in data analysis. I will spend some more time in grounded theory because it's one of the most well-known techniques, the prince of qualitative research analysis, if you will, and then some few tips and tricks on evaluation agreement, because I know you guys and girls have done some of that as well, so we'll deal with that at a single study. So first of all, we have talked extensively about the need of qualitative research. What is a qualitative study? What does a qualitative study entail? Now, first of all, anything qualitative amounts to understanding an unknown domain using qualitative data. Qualitative data is data describing observations, right? So populations, activities, behaviors, actions, anything that can convey an observation or the meaning of an observation, that is a piece of qualitative data. For example, suppose you are observing a phenomenon. When is this phenomenon taking place? That's a qualitative factor. How is this phenomenon taking place? That's another qualitative factor. Who is responsible for this phenomenon? Who came about? Who played a role in this phenomenon? That's qualitative data again. Essentially, the process of a qualitative study consists of inferring all sorts of recurrent concepts emerging from such qualitative data. Let's suppose you are building a data set for a weather prediction forecasting machine learning model, right? You need to study weather and how to forecast it. You study weather, you observe your window for like a year. You observe leaves moving, you observe the wind, you observe rain falling. All of these are qualitative factors. Every day is a qualitative data point because you can capture the data, you can actually take pictures of the data, you can record it. You can listen to the sounds, you can record these sounds and then analyze them at a second stage. All of this is all very valuable qualitative evidence. Now let's move forward. Suppose you have your qualitative data. You might have interviews, for example, you might have observations, whatever, in-field descriptions of activities. Essentially, different types of qualitative studies entail different kinds of qualitative data. So it is also up to you, the analyst, to combine the kinds of qualitative data with respect to whatever research questions you have, right? So interviews is one thing. I know you guys have spent some time on interviews. I will not spend too much time on them. You might have blunt, raw observations. So, for example, taking pictures of the window if you want to study the weather. You might have documents in case you are studying software architectures, for example. You have software architecture documents to study and code and whatever. Now, regardless of the kinds of data, the design needs or plays an even more important role with respect to quantitative counterparts. First of all, because the design is totally different. The focus is on not being able to control whatever variables you might encounter in the scope of your qualitative study, but trying to understand really what dimensions you are looking for. If you are interested in looking for variance, for variables inside your study, then you need a time-resolved qualitative type of qualitative design. Also, typical principles which are valuable in terms of quantitative studies like randomization, data balancing, blocking or stacking of the data, they don't really make sense, right? So there are ways in which you can control factors for the data gathering phase. For example, if I'm studying documents of software architectures, I can go in 10 industries which cover a sufficiently large spectrum of sectors for me to be able to claim some form of generalization. But also keep in mind, qualitative studies are not designed for generalization. Qualitative studies are designed for understanding. If I want to understand the behavior of my wife, or my fiance actually, she's not my wife still, although in my own heart she is already my wife. Alexander knows her very well. She's a good kid. So if I want to try and understand her, it will take me a lifetime probably, and I will not even understand it fully. But I could study her behavior for like 90 years. Supposedly, I will live 90 years. Let's say 70. That's more realistic. I burned a lot of my brains while I was doing my PhD. So let's say 70 years, realistically. Every day I will report on what her behavior might be, but I will never be able to generalize that behavior to, let's say, up to, let's say, 10 humans out of 7 billion. Not even. I would say there's no one like her. She's nuts also. No, she isn't. But anyway, the problem and the point here is designing qualitative studies has everything to do with understanding, and it has relatively nothing to do with generalizing. I'm saying relatively nothing because it is up to you, the designer, to find tricks, find ways in which whatever observations you are capturing can be elevated to a point of generalization. So that is one of the key threats to validity that you will necessarily be called to discuss. Now, the reason why the designs are totally different also implies that there's no single bullet in designing designing for qualitative research. That is also the reason why there are strategies to design for qualitative research. There's a few more besides these three, which I'm reporting. These three are from an epistemological point of view, so scientific research philosophy point of view, are the major ones. So naturalistic inquiry, emergent design flexibility, purposeful sampling, and I think I cannot stress enough, they hardly or do not allow generalization. Now, each of these three has specific characteristics, and let's say they can be casted onto whatever research design, whatever research problem you might have at your discretion. So, for example, naturalistic inquiry and the strategies to design for naturalistic inquiry, it means you are studying real-world situations, real-world scenarios, and you are not supposed to have any sort of constraint. The typical approach in naturalistic inquiry is ethnography. Ethnography means you yourself, the analyst, are embedding into the naturalistic setting that you want to study, into the real-world situation that you want to study, and you want to capture all data, regardless of what that data is about. Imagine you are an anthropologist and you are studying a remote Central African tribe. You want to go there physically and observe the tribe without intervening in any of the tribe's processes, and you want to capture hourly or daily notes about what is happening, and then you want to analyze that data. That is a path of naturalistic inquiry. Let's do one more. Emerging design flexibility. Now, this is, again, a strategy. It's not really a fixed notion of a design. But essentially here, you do not have any fixed design. You essentially vary the design based on what every new data point brings in. This is typical with interviews, for example. You start with one interview. You do not fix the amount of interviews. You start with one. You analyze the data, and then you do one more, and then you analyze the data, and then you do one more, and then you analyze the data. And this leads to slight incremental tweaks and changes into the research design. Now, typically, emerging design flexibility is accompanied by purposeful sampling. It means you are not selecting your sample randomly. You are not even controlling your sample. You are leading your sample to the discovery of your theory, which means you want to select the samples that are most appropriate to giving you the information that might lead to the discovery that you are looking for. This doesn't mean confirmation of things that you already think. That's not the point. You are not supposed to encourage people to tell you what you want to know. That's not science. That's a degree of magic. We're scientists. We don't do magic. One takes brains and the other one takes black eyeliner. And you are scientists, so you have brains. You are not looking for people to confirm your ideas. You're actually looking for people to disprove your ideas. Now, let's suppose you have your designs. And by the way, there will be, I presume, some time for questions. So by all means, let's definitely spend some time on questions. So let's deal with the questions. Even in runtime, feel free to use the chat to throw in questions. It's completely fine. Thanks, Alex. Yes. So again, assuming that you have selected one of these strategies. Now, I don't want to go deeper into these strategies. We don't have time to go deeper. I will give you a lot of these concepts. Now, I presume you will also go to some of the references which I left at the back of the presentation, but also just use Google. There's so many, there's entire sectors of epistemology that are looking at figuring out ways in which qualitative research can be structured even further. So I don't want to give you any further insights. Just go and take a look at the different state of the art in these sorts of sectors. Because, by the way, some of these sectors actually evolve even quickly than I myself have time to document about them. So again, let's presume you have chosen your design strategy and you have documented yourself on how to build your design. How do you analyze the data? Can you design your study to have an analysis strategy up front? Now, because of the nature of qualitative studies, when you design for qualitative research, analysis itself is not a definitive process. It's not like, hey, I want to apply machine learning, I want to find patterns, I want to do association rule mining. This is a completely different setting. Again, we are talking about strategies, and these strategies derive from what kind of problem you have at hand. For example, let's suppose you are an analyst that is trying to figure out what is happening in Chernobyl. Chernobyl exploded. It's a large nuclear disaster. You are doing root cause analysis. You are doing what if analysis. Now, both root cause analysis, what if analysis, or critical factor analysis are declinations of what is known as unique case orientation. It means you are observing a single case. You want to go deeper, as deep as possible into that case, into whatever characteristics that case exhibits, and you want to consider it by itself, alone. Now, there's a lot of people who actually do this unique case orientation for years and years until they have a coherent set of cases that they have studied, and they find patterns which are across. Also, spoilers, you might have figured this out already. Qualitative research takes much longer than the typical quantitative data scientific exercises. That's why my data science students don't like it that much. But mind you, the only way in which you will make your data science useful is by doing sound qualitative research first and after. There's no other way. Sorry. Maybe you're geniuses and you can invent a new way. And I condone that, definitely. But so far, there's no other way. Just deal with it. Now, again, unique case orientation. Beyond that, you have inductive analysis and what is known as creative synthesis. Essentially, you explore the cases with less depth, but you compare them constantly. So you take one case, you study it, you synthesize some data, and then so you induce some form of theory, some form of theoretical understanding, and then you compare that theoretical understanding with yet another case, and then you induce some more theory, and then yet another case, and then some more theory, and then yet another case, and then some more theory. This process of synthesizing the theoretical, what is known as the theoretical understanding, so the knowledge, the theory that you are generating, is called creative synthesis, because at some point you will be able to take the process, distill the patterns and commonalities between every single data point or observation or unique case you have been observing, and you might be able to synthesize your own results as well. Last but not least, you can also keep a holistic perspective, which means you want to capture the domain and maybe model the domain itself with a conceptual model. This is typical for taxonomy analysis, for example, in which you are building a taxonomy, or ontology engineering, in which you are building an ontology, so a series of concepts with relations. And again, there's all sorts of structured approaches to do it. The most formal is known as formal concept analysis, which I'm not recommending to apply because it's very expensive. But it's also a lot of fun. You should do it at least once. Now, there's a few more strategies. Now, the ones that I'm reporting here in the slides are the most used ones, the most adopted ones, and also the most recurrent ones in the problems that you will face, for example, in industry. I want to spend, so context sensitivity is really a slight variation with respect to holistic perspective analysis, because in context sensitivity, you are focusing on the context of a phenomenon as opposed to the phenomenon itself. Now, this means, for example, focusing on let's say the behaviors, the patterns of a city, as opposed to the incident that took place in that city, right? So the historical, the temporal, the variables involved in that context, and so on and so forth. Now, the last one is not really a strategy, is more a few tips that I want to give you. Subjectivity is by design embedded into qualitative research. That is also why, and most especially why, qualitative research necessitates, requires inter-rater reliability assessment. It requires inter-judge agreement. It requires you, the researcher, to balance the subjectivity of the subjects and also of yourself, right? You cannot be fully 100% objective. So you need to be able to harness your objectivity and try to find a way to discuss it with somebody else, maybe your co-authors or somewhere, your supervisor, whatever, or just increase the sample of people that you're looking at. That usually warrants for some form of, reflexivity and generalizability. The principle, the mark that you are supposed to hit when you have a qualitative analysis process is known as theoretical saturation. Theoretical saturation means you have your research questions, you have your data points, analyzing these data points over and over again. No added data point brings up new information. That is theoretical saturation. It means you have reached a point in which nothing can bring new information into your observations. This is very critical, and that is also why I did not put it in the slides, because you should listen to me. Believe me, if you cannot find a way to show practically, to demonstrate, to defend why your qualitative study has reached theoretical saturation, I, as a reviewer, would reject that study very easily. That's off the top of my head one of my favorite rejection for manuscripts or thesis or PhD thesis or whatever endeavor. Is my favorite go-to. If you cannot show that you have reached theoretical saturation, it means you cannot show that you have explored the domain, the problem, the context to an acceptable extent. So, theoretical saturation, essential principle. Deal with it. Capture it. Remember it. As a matter of fact, I sent Alex questions. Alex, remind me to send you a question for the quizzes about theoretical saturation. Remind me again, because I will forget in like 2 minutes.
Absolutely.
Yes, thanks, dear. So, so some qualitative approaches. These are types of studies which are concrete instances of all of the things that I've just said. I have instantiated each of these ones, so I can tell you a bit more if you want to know more. And together with Alex, we have in fact instantiated some of these as well. So, for example, reality testing. Now, keep in mind, if you have a complex phenomenon at hand, there's a very good chance you will have to combine qualitative research with quantitative research. Now, in most, if not all of these studies, the design started with a qualitative angle, and then it eventually led to a quantitative angle. This is, if you think of it, unavoidable, because qualitative means understanding a specific domain. Quantitative means quantifying that understanding, the extent to which you can come up with an effect size, for example, or the extent to which there are trends which are statistically relevant, for example, which are measurable to some extent. So some of these approaches reflect, again, naturalistic inquiry, like ethnography, We have spent some time on ethnography as well. Some of these are reality testing. So suppose I've studied Chernobyl. I have a theory on what happened in Chernobyl. Can I test that theory? What if I go to another nuclear disaster? What is going on in that nuclear disaster? Is the same timeline, progression of the phenomenon also manifesting? Is there a same recurrent pattern for the explanation that I can see and witness in the real world? Constructionism, let's put constructionism aside for a second, because I will deal with it in grounded theory domain, because constructionism and grounded theory are very much intermingled. So let's deal with that in a second. Phenomenology essentially deals with the phenomena that have to do with people. And keep in mind, people, data science is about making the life of people easier, whether it is businessmen or humans of some kind, or semi-humans like myself and Alex, for example. We are very much semi-human because we're hardcore professors. Actually, Alex is a professor. I'm a young and upstarting associate professor. But we consider ourselves, I consider myself demi-human because I work for science. Right? So phenomenology means studying a phenomenon with respect to the people, the entities which are encapsulated in that phenomenon and experience that phenomenon. This also goes back to the deployment issue that I was telling you about data science. What do you think happens if you don't know what actually happens to the humans that have to use your data scientific model? Let's suppose you have a beautiful, well-predictive data science model. You go and you deploy it. How you deploy it, how valuable is the deployment mechanism if you don't know who you are deploying it to, and who and what that person is looking for, and what business understanding does that person need to gather from your deployment of that machine learning model. These are essential research questions of a qualitative study, a user study, which happens to be a phenomenology study, with respect to the deployment of that specific machine learning model. There you go, phenomenology. Now, there's some more, which in your case, or rather, the ones that I'm showing you here now are slightly lower in the level of abstraction with respect to the previous ones. Now, the first two, narrative analysis and ecological psychology, I don't think you will have anything to do with these approaches, because on the one case, you are inspecting narratives. However, I've seen a narrative analysis study being conducted in the scope of software architecture decision making. So how does a software architect come up with a specific decision? How is his or her process interpretable? What are the recurrent variables in that process? Same goes for ecological psychology. We ourselves have enacted ecological psychology in the scope of DevOps. So trying to figure out how do people try to embrace DevOps practices, right? So they have specific goals. We capture the goals. We capture the ways in which they try to adopt and address those goals, and we try to generalize patterns out of that. Grounded theory, let me not spend time on grounded theory because I have an entire section about that, and also that is related to constructionism. So let's skip these two. Let's table those for a second. Let's move slightly forward because I want to ask you a quick question. Which one you think fits best, and here we are talking about study types, which one fits best with data-intensive research? And by the way, data-intensive research is also what you are doing when you're doing data mining, when you're doing big data engineering, when you are doing machine learning and general data science. That's still data-intensive research. So which one? Ethnography, reality testing. Now these are known as reality-focused qualitative studies, or conversely, phenomenon-focused qualitative studies. So phenomenology, narrative analysis, ecological psychology, or as opposed to hybrids, because that's what grounded theory really is. So grounded theory really captures reality by focusing incrementally on phenomena. I will show you how and why in a second, but let's not spend too much time on that. A, B, C, or all of them? D. What can you tell me? Come on, give me your best shot. Again, start a poll. Let's do this. I love it. A, B, C, D. Go. D, all of them. Yes. Yeah, it's the easy go-to. Come on. Yeah, that's the easy go-to. I might have given you the answer already. Okay, so there's a few bees. Bees, I love bees. You know, bees, the insect is responsible for our life. Without bees, we would be able to resist about 90 years. That's not good. Then we have C. Okay, we have a few C's. A couple of C's. It's good. So C is, what was C? Okay, C was hybrid. Okay, so C, I can excuse the C's because I take part of the fault. Spoilers, C is wrong. So it's not only grounded theory because it's a hybrid approach, definitely, and it is in fact applicable. But here we are talking about the ones that fit best. So it's not only grounded theory. But I take part of the blame. So it's my fault, right? Because I haven't gone into grounded theory as well. Sorry. Okay, so waiting responses. There you go. 10 out of 17. Have we achieved statistically relevant samples? 10 out of 16. Okay, I can wait for a couple more. No, Alex and Nathan don't count. So that's 14. And I don't count either. So that's 13. Okay, so that's fine. Let's do that. There you go. So we have B's and D's. We have agreement, more or less agreement between B and D. That's quite good, but there you go. Go figure. All of them are best fit for data-intensive compute research endeavors because, as it usually happens for computer science, it depends. It depends. There's no one best fit. As it usually happens, especially in the realm of qualitative research, you don't really have a specific silver bullet solution. Indeed, grounded theory is in general the most preferred because it is in fact applicable to all sorts of domains. But the best possible design is only such if it matches exactly the goals that you as an analyst set forth together with the committers of the study. So if you take CRISP-DM, for example, CRISP-DM, the process for data mining starts from defining precisely the goals of the study. Because when you have defined those goals, then you will figure out the research questions, and then you can figure out what is the most appropriate qualitative research approach to start with, qualitative research strategy also, qualitative analysis strategy, and so on and so forth. All right, so I would recommend we take a look at this example, and then I would say we do a short break, because there was a break foreseen, right, Alex? It was a break, right? Yes. We can also do a shorter break if you guys want, like 10 minutes, 5 minutes. So the example I want to bring you on the table is how to instrument an ethnographic study. Now, the problem I had during my PhD, as a matter of fact, was I needed to know what an organizational structure which was dealing with a large-scale software artifact, how that organizational structure was behaving from a social and social-technical perspective. I needed to know variables, roles, forces at play, patterns, also in principle, thresholds of high and low for these variables, right? So whether it is, if it is, for example, informality in the communication among people, is that high informality, or can that be considered high informality or low informality, and so on and so forth. So this was my research problem. What I instrumented was what is known as a cognito field study. It means the people in the field knew that we were conducting the study on them. What we did is go and embed ourselves into an open source community, study and contribute to that open source community for about 8 months, taking field notes every day. These field notes were deliberately unstructured because the field notes represented the capturing of the phenomenon being observed. And then at the later stage, we analyzed the data, because these field notes and the communication reports and the logs of our contributions were analyzed through various means, content analysis and also grounded theory to some extent. And we were able, in fact, to figure out factors at play, forces at play, levels, so high or low, for these factors for this community. So for this community, we were able to say, hey, this community has high informality in this respect and low formality for that respect. And this was only possible by instrumenting this ethnographic study. Okay, you might say, hey, but this is 8 months. We don't have 8 months worth of time to spend in this life. Sorry. I'm so sorry. There's just no other way. Qualitative research is very expensive. Just deal with it. There's no workaround to that. Okay, so enough about this example. There's also, I can also tell you a few more in case you want to know. I presume we can take a short break now, right, Alex? Nathan? What do you think? Okay, short break. Is it like 10 minutes or 15 minutes? How much? Do we want to do like 2:30? Now it's 2:17. 2:30, okay? Yeah, we can do 15 minutes. So we do 2:30. 2:30. What is it? 2 times 3 carry the 2. It's okay. So let's do 2:33, right? 2.33, right? There you go. Okay. So meet you in, what is it, like 15? Be good. Hope you're enjoying it so far. Ciao. I'm gonna go for coffee. Okay, let me start sharing my camera again. The session is being recorded again. Right. Okay, so let's move forward. We did this example. I hope there's, if you have questions about this or anything between questions, comments, thoughts, remarks, doubts, issues, curiosities, just fire away. Don't feel scared. That's why I'm wearing a hoodie. A hoodie is much more friendly, and this is Gas Monkey Garage hoodie is big stuff. All right, so let's move forward. That's the reason why I wanted to stop there, is because now we are entering more the realm of, you know, the comparison between what it takes to design qualitative versus quantitative. Now, again, keep in mind that qualitative means strategy, quantitative means control factors and explicit decisions. Strategy, as opposed to decision, explicit decision, means you have intentions at the level of qualitative study, and you have tactics at the level of quantitative ones. So explicit decisions. Obviously, for any strategy, the efficacy of any strategy bows down to evaluating trade-offs. Now, these are the typical design trade-offs. There's all sorts of books that you can go and take a look for qualitative design, qualitative research design trade-offs. These are the typical ones, and my favorite is depth instead of breadth, so the extent to which you want to go deep instead of the extent of generalizability, so breadth that you want to cover, as opposed to constraining the qualitative analysis to go deeper into specific issues with maybe a quantitative lens. So for example, if you focus on a specific issue, you can actually code the recurrence, count things, right? So count recurrence of factors, count occurrences or patterns. This is typically called content analysis. So the transposition of qualitative into quantitative data. So counting things, counting codes, even things like that. So one more is the extent to which you want to use standardized approaches and questions. So for example, the extent to which you want to constrain your own survey to be in a Likert scale fashion. So to what extent do you agree with this statement? To what extent, 1, 2, 3, 4, 5. To what extent do you agree with that statement? So this is a constraint that you are adding. You are constraining the research design space into boundaries which are polarizing that research design. So this is a trade-off that you also need to come to grips with. Again, qualitative is not also standing on its own. It can be mixed and matched with quantitative studies. However, we are entering there in the realm of mixed methods research, and I will not spend time in that because that would deserve its own maybe slot or course entirely. I'm a big fan of mixed methods research, but it's a whole different monster. It's a mess. Let's not even go there. Let's spend more time on what trade-offs exist actually with regular qualitative design. Now, keep in mind, you will always be faced with these issues. That's also the reason why I'm reporting them here. And go figure, in the scope of data scientific endeavors and data engineering endeavors, a pilot study is pretty much 90% of the cases the first thing you will do. Now, pilot study is a theoretical formulation phase in which you are, in fact, by design constraining your hypothesis space, your research design space, but then you start from the pilot study and you enlarge it into a wider, larger scale study. So each of these issues can be solved with incremental research designs. So you start, for example, from a pilot study, and then you move into a deeper, more elaborate research design. Because keep in mind, the typical research designs in qualitative research also include a time dimension of the research design itself, of the analysis that you can conduct. So for example, you might need to come up with a response to a specific question and then elaborate on your response to another question, and so on and so forth. From a evaluation, so how do you evaluate your research design? How do you know whether your design is good or not? There are tips and tricks that you can use. I'm reporting a few of the ones because these are the sanity checks that I myself apply in terms of meta evaluation for the research designs that I myself conduct. These are the typical fallacies, right? The pitfalls, the small sample size, for example. For example, you're interviewing 5 people. Why is 5? I've seen this 5 popping in and out left and right. Why would 5 be a good number? It's a number which is extracted off the top of the hat. Maybe it's close to Likert scale. That's why people love it very much. The number needs to be, in principle, statistically relevant. So if it's a company of 30 people, then 5 is acceptable to represent that company. 5 is acceptable as long as you verify the theoretical saturation principle. You remember theoretical saturation? Alex is reminding me that I have to send you a question about that. And small sample size is a typical mistake that people make. And small is small, right? So small is relative because it also amounts to how big is the actual sample, the context that you're observing, and so on. Also, selectivity bias. Have you asked these people to volunteer? That's a selectivity bias. Sampling bias. Have you yourself selected the parameters with which you want to sample your population? Are you only asking your friends? There's a sample bias right there. Let's not spend too much time on these. Keep in mind, this is some sort of checklist that you can use to do some sanity check. There's all sorts of checklists out there as well. This is just a non-exhaustive one, so also take it with a grain of salt. We don't have too much time, but I want to spend some time on interviews. This portion here does not tell you how to run interviews. I know you have spent time on that as well. I will just give you tips on how to make sure the interviews are effective. Informality helps. Informality helps always because people will reveal information which is not constrained by formal interaction. Formal interaction constrains interplay between people as well. Informality during the interview helps, but also you need to be able to show that your research design featuring interviews is rigorous enough, which means you need an interview guide. An interview guide approach shows that the research design is at least partially replicable. So you can, in fact, reenact the same study. In terms of interviews, I've seen closed interviews or fixed response interviews. They are to be, in my opinion, discouraged, because a closed-ended interview is essentially a subsidy for a survey. If you really want to run a survey, then just run a survey. Don't waste people's time because of whatever effectiveness or of the study, or you want to capture the emotions, the reactions of specific people. That's something that you can do. So you do a closed fixed response interview to study the reactions of people, but then you need to record the interview as well visually, because the focus of your study is on the reactions of people with respect to specific questions, as opposed to the answer to those questions. Does that make sense? And also, last but not least, conducting interviews. Let's go back to my tip of using informal and conversational. You will get a lot of extra information, including extra questions. That's also why I like it. Extra questions are good. Questions are your friends, especially when you are doing interviews. First of all, a question is the basis of science. There is no science if you don't have research questions. Follow-up questions are typical with open-ended interviews, conversational, because those are the kinds of research devices that will lead you to follow-up studies and or boundary cases. Because people that comes up with boundary cases, they will do it as part of their thought process, their cognitive process, going about inside their brains while you conduct the interview. And the same process is enacted by you, the observer, which will lead to follow-up questions. And this is precisely what would lead to eventual follow-up research studies. So you get essentially the research roadmap section of the paper almost for free. Again, this informal approach is or needs to be combined with the interview guide approach, because obviously this constrains and offers grounds to the reviewer of the study to give credibility to the study. Keep in mind, the interview guide can also be augmented after the interview with all sorts of follow-up questions as instances, because these are part of the interview process as well. Augmenting the interview guide is not a problem. It is a good thing if you have valuable data to add on top of it. It doesn't mean modify the previous version, it means augmenting it. So an appendix, some extra material to be added to the interview guide approach. Let's move forward. Enough with tips about this. Let's also skip the open-ended interviews and the closed fixed response. I'm also leaving you tips on the kinds of questions, because a lot of people, when they are structuring their interview guide, they don't know what kinds of questions to ask. Now, this is a typical checklist that I myself use. By the way, I will publish the shit out of this material. I promise. I haven't gotten around to do it yet. I will at some point. So you might find it in a paper, methodological paper at some point, hopefully next year. I don't know. I'll see. But please take heed of these kinds of questions. There are also taxonomies out there that you can use, depending on whether your study is exploratory or confirmatory or longitudinal. So please take a look at these taxonomies. They are very good reference material for you to conduct your own interview study. Now, moving forward, besides the recommendation, let's just skip these recommendations as well. I don't want to spend too much time on this, because I know you have already spent time. I left this material as a reference. I didn't plan to discuss it further. If you have questions on this material as well, we can also follow it up. There's no problem. I'm also leaving you an example of a decent interview guide from a previous study of one of my students. So go and take a look, right? I don't want to spend too much time on this, because I know you have already dealt with this material as well. I would much rather want to spend time in the data analysis phase, because it's, go figure, one of the most interesting. Okay, data analysis, the gospel of qualitative research, the key difference in gathering or rather, in conducting qualitative empirical software engineering or empirical research in general is also in data analysis. Now, data analysis, as we have seen, involves all sorts of approaches. So boundary case analysis, such as case study approaches, case study research, analytical approaches, storytelling approaches. Storytelling, for example, was used, by the way, as a matter of fact, it was used to conduct root cause analysis in the Chernobyl disaster. Storytelling means you are fleshing an entire phenomenon as it unfolds from a time-resolved perspective. Chronology is a typical approach to build what are known as fault lines. So if I have a timeline with a specific phenomenon, whose fault was a specific event, and who or what object, what entity carried the fault for a specific activity that led to a specific failure, right? So all of these would figure out as storytelling approaches of analysis. So building a chronology. We did this as of late in a study in which we were trying to figure out why SourceForge failed. You remember SourceForge? SourceForge was in the good old days when Alex and myself were kids. We used to contribute to SourceForge. GitHub was not there, it was not even invented yet. This was 98, 2000, let's say. So in those good old days, SourceForge was the gospel of the geeks and nerds like me, contributing code to open source communities because GitHub was not there. So SourceForge actually declined over the years. We used the storytelling approach. The paper is actually published, it's out there, you can go and read it. We use the storytelling approach to figure out how and why it failed, because that might be interesting for people who are running similar forges or similar, community, software community hosting exercises and tools and approaches. Now, in terms of these approaches, however, these reflect more the organization of the data rather than the actual analysis of the data, so to extract meaning. It does aid the meaning extraction exercise, but for example, storytelling approach will force you to reorder events and your data in a time-resolved fashion, right? So explaining flashbacks, for example, things like that. Just as analytical approaches will, in fact, focus on extracting recurrent numbers and of patterns of occurrences, for example, like content analysis, which is the example that I made. Yeah, thank you, Alex. That's exactly the one. So this is my question to you. Let's focus on the organization of qualitative data. Which ones have you encountered in your own practice, in your own endeavors so far? This can be anywhere, right? In your assignments, in your previous thesis, in your PhD, if you're doing a PhD still. Let's take a look. Let's start a poll. Okay, instead of 1, 2, 3, 4, just use A, B, C, D. There you go. Go ahead. Give me a bit of shot. That's a case study. I knew it. I knew it. Everybody's doing case studies. It's unbearable. Yeah, case studies. I'm a big fan of case studies. I was responsible for writing the standard, the ACM SIGSOFT standard in executing and evaluating case studies. Alex, your course students have done case studies exclusively. Oh, this is good. Okay, so now for your thesis, I expect you to, maybe I will be partially responsible for your thesis. I don't know. But if I am, I expect you to not focus on case studies alone, but enlarge that type of qualitative data analysis organization approach to a wider agenda. Because case studies are fun. I'm a big fan myself, as you know, as Alex has shown you. But there's so much more, right? Don't presume that case studies are the bulletproof solution. As a matter of fact, they are the easiest, well, not even the easiest to sell. They are amongst the ones that can be written out in a more straightforward and convenient fashion, and they are less difficult to design. I'm not saying they're not difficult. They are less difficult to design. But you shouldn't go for the easy way. You're scientists, damn it, which means you eat difficult for breakfast. So please, next time you're faced with a research problem, you should go and look for the difficult alternative, because difficult is cool and we eat difficult for breakfast. Now, enough about this. Let's do a follow-up. Let's say you have organized your data in such a way that you want to conduct, for example, a storytelling study or a case study. What do you do if you have the data and you want to analyze it? There are epistemologically two ways to analyze qualitative data: inductive analysis, deductive analysis. Inductive analysis means you first discover patterns in your data, themes, if you will, and then you come up with a theory. Deductive analysis, it means you have an existing theory, you have a series of theoretical formulations, what is known as theoretical framework, and you want to evaluate the extent to which that framework matches the theory. Now, there's no one silver bullet way. There is just a tip that I can tell you, because each of these two amounts to explaining different things of a specific qualitative phenomenon, qualitative research design. So you normally start with inductive, because you are looking for patterns in an unbiased way. So you look for patterns, you look for recurrences, you look for quantities as well. You can also look for quantities, recurrences, counts in the collected data. And then you deduce the theory, forming with a deductive exercise. This is precisely what happens with grounded theory. Now, what you see here is a recap of this exact scientific inquiry approach, or scientific discourse, as the philosophists call it. Now, Claes Wollin is a beautiful, a brilliant empirical software engineering researcher and analyst. He also wrote the book, I would say, for empirical software engineering, which is Experimentation in Software Engineering. I think that's the name of the book. I have the reference later in the back of the slide, so you can go crazy about it. So this is exactly a recap of what I said here. You have induction, then deduction, then induction, then deduction, and so on and so forth. This goes on and on until no data point reveals new information. So theoretical saturation has to be achieved when you gather the data and when you analyze the data. So no new data point tells you a new story. No analysis of whatever data point tells you extra information, which is interesting from a hypothetical or theoretical perspective. There you go. Theoretical saturation. Again, I will send you like 4 questions on theoretical saturation, Alex. No, 4 is too much. 2. I will send 2 questions. Theoretical saturation. I cannot stress this enough. Okay, let's move forward. Let's do a bit more about these two. Inductive analysis, what does this mean? It means you have indigenous concepts and practices which are hard-coded in your data. Let's suppose you have documents which are describing your software architecture. There are concepts which are reported in that software architecture. There are practices which are either implicit or explicit. You want to extract these indigenous concepts. How do you extract them? You label them. You can crosswise the document. You can draw a circle around it. You can add label to it. Hey, this concept reflects trade-off analysis. This concept reflects architecture driver. This concept reflects architecture tactic. This concept reflects architecture issue. This concept is a stakeholder. This guy is this and this and that and the other thing. So this is how you locate and extract indigenous concept. Sensitizing concepts means you do this exercise over and over and over and over again, and you come up with a general taxonomy of these concepts. That is your domain model, because it describes the concepts that have emerged from your own investigation of the indigenous concepts. It's a conceptual model. Of course, the data itself will also contain what are known as indigenous typologies. So, for example, if you have a recurrent series of people inside an architecture document, these people are likely to be stakeholders, but they can be internal to the project or external to the project. This is a typology which is hidden inside the document. So these can be either explicit in the document, in which case they are indigenous, or you can construct them in your own analysis exercise. You can construct them by incrementally looking at the data and identifying the recurrent concepts and the different levels of abstraction for these concepts. Now, keep in mind, this is the phase in which you are introducing a gazillion of threats to validity, more specifically threats to construct validity. Because go figure, the typology in question is a construct. It's something that you are extracting from the data. Either it is indigenous, which means it is an indigenous construct, or you are constructing it yourself, which is an even more biased construct. So you need to discuss. There's no way to avoid this. This is by design. It's built in. You cannot avoid it. You need to discuss a threat to validity. Remember, a threat to validity does not diminish the value of a study. A threat to validity enriches the study because it delimits the scope under which that study, those findings, those lessons, those observations are actually valuable to the state of the art and to the state of practice. So inductive analysis, deductive analysis comes after because deductive analysis usually or typically amounts to gets the indigenous concepts, the practices, and forms categories inside the inductive classification exercise. It all starts with what is known as coding. Coding is the labeling exercise that I told you about. I will show you how the actual coding takes place in a second. A lot of students ask me, how do I code? You think of coding as, coding. I do a lot of this. That's, by the way, why I'm wearing these gloves. These are compression gloves. They're medical gloves because I have a lot of, skin problems, because I have arthritis, because I write too much. Anyway, coding is the process of recurringly looking at the data and labeling the data itself. Every piece of text is a data point. The process of identifying the minimally labelable increment of data, that process is called microanalysis. From an architecture document, I can code a single sentence. I can code 3 words. I can code 1 paragraph. I can code an entire section. I can label sub-portions of this section. Those are co-occurring instances, because I can also figure out ways in which these co-occurrences recur over time. In principle, the exercise, which is deductive, comes up with categories. A category is essentially a way to encapsulate more than one code under the same concept. That's a category, right? Obviously, category should have internal homogeneity and high external heterogeneity. So for example, if I am coding issues on GitHub, a category could be functional issues. Another category could be non-functional issues. If I do functional and non-functional, these are very much heterogeneous externally, but they are internally very much homogeneous because each of the members of the functional category will have functional issues, and the same is true on the other side. This is pretty much the same as good cohesion, low coupling when you do object-oriented design. It's just the same. You're just applying the same principle. You are computer scientists, you are software engineers, you are data scientists, you are scientists, which means you have been trained. Your brains is rigged to do this exercise. So don't go telling me that qualitative is difficult. You eat difficult for breakfast. You should, because you're good, because you're scientists. You work for Madame Science, and that counts. These are, again, me helping you in terms of figuring out what makes a good categorization schema. these are just parameters that you need to apply. These are sanity checks. There's more. If you go and look to the book by Clarence Strauss or Henry Glaser, who introduced grounded theory, you will find these also further elaborated. I don't want to spend too much time on this, but just keep in mind, you have this material also for future reference. I obviously will send you the slides. I think you can already download the slides, by the way. So please go crazy with this. But let's not spend too much time. I do want to, yes, the slides are in canvas and files. Yes, thanks, Alex. I do want to spend time again with the integrated reliability assessment. I know you have spent some time on this, but I cannot stress enough the necessity for having manual classification through multiple observations and multiple observers of the same data. You have different interpreters, different labelers, if you will. Now, these different people apply specific label. You will need to apply indexes such as Cohen kappa, Krippendorf alpha, adjusted Cohen kappa, what have you, to understand the agreement to which these people agree that this concept is reflecting this code as opposed to this code. So you need to have an evaluation of the extent to which these people agree between themselves on the coding schema, because this will make sure that your coding schema is not only valuable from a scientific perspective, but also it contains knowledge which is in principle transferable. And this reflects multiple evaluators. Obviously, there's ways in which you can think of instantiating this exercise into, for example, even data scientific approaches. For example, bug classification. Anywhere you have labeling, you will need this sort of exercise. I cannot stress this enough. Measuring the agreement is also something that you need. It is not sufficient for you to tell me, I have conducted inter-rater, everything is fine. I don't trust you. I want to see a number that tells me the extent to which you have agreed with another arbiter, or you can tell me how you dealt with the inconsistencies. Because inconsistencies are going to be there. If you tell me there's no inconsistencies, I can tell you're lying, because inconsistencies are by design there. Because this is biased by design. All right, so again, there's a lot of literature on all of these. Now, let me ask you, have you ever encountered some of this literature? Maybe you haven't. If you have time to go and take a look at this literature, Alex has already shared this, I think. It will become a SIGSOFT note, technical note. It should be. It was supposed to be by the end of this year. There's all sorts of such documents out there about each of these. So go and spend time on gathering a basis, especially if you're doing a PhD. Gather a basis of these documents, because these are arrows in your quiver as a scientist. So never forget this. Okay, let's be serious now. Let's spend like 10 minutes on taking a look at doing this practically. This is grounded theory, the prince of qualitative research methods. And go figure is also the ones that pretty much everyone prefers, because, so grounded theory reflects to constructionism. Constructionism means you are starting from data that maybe you yourself didn't even gather, and you want to figure out a theory over that data with an incremental iterative approach that doesn't start from a theoretical framework. So you want to start unbiased. Grounded theory is also very much used because it starts with zero assumptions of knowledge from your end to the data. So in principle, if you, for example, want to classify flowers in the field. How do you classify flowers in the field? You want to produce a deep learning module that identifies flowers using drones, for example. By the way, this is actually something that we are in fact doing with Naturalis, whom you might know. It's in Leiden. They're good people. Now, how do you do it? How do you approach this domain? This is a complex domain. This is biodiversity stuff. I can tell you this is pretty complex stuff. This is biology stuff. I know these biologists, they're nuts. They're worse than we are. So, so how do you approach it? Okay, you instrument a grounded theory study. How do you instrument your grounded theory, for example, case study? Grounded theory is structured as follows. You capture a specific observable phenomena. So you follow the practitioner on the field. He is recognizing flowers. You are following him. You're capturing him. You can take a camera at him, for what I care. You can observe and document. You can write it down. You can film him. However you want to do it. You observe the phenomenon. You gather the data, and then this is an analysis approach. So you label that observable phenomenon. Then you discover categories across that phenomenon. This is exactly the categorization exercise that we just said. And you further elaborate on those categories. So you come up, for example, of categories that are in fact properties of a specific category. So you essentially build the conceptual model incrementally by labeling over and over again the data. This process is called constant comparison. That's right there. Right there, top right. You have your data set, you have your categories, you're doing micro-analysis. So you have, for example, your document with which you have documented the proceedings of this guy going in the field labeling flowers. And you are constantly comparing portions of this document and portions of other documents, such as the one that you are analyzing currently. What you are also doing is leaving annotations to each of the labels that you apply. This annotation is a piece of the theory. For example, you are saying, hey, this guy is picking this flower in this way because this flower is particularly lenient to this type of label. You cannot label it because you ruin it by picking it in this other way. That's a memo. That's a part of the theory which is emerging by you analyzing the data. This memo tells me that specific action, that specific approach in that specific document reflects a property of the act of picking flowers for labeling. That is a memo that you are leaving, but it also reflects a specific sub-category, because that specific sub-property is in fact a sub-property, is a property of the category that you have already devised. The category could be, for example, flower picking. The property is picking in this specific way. Now, the more you do this exercises, you will have what are called core categories. So categories that include other categories, right? So categories which are incrementally of a higher and higher level of abstraction. Now, there are ways in which you can structure this approach. So the open coding approach. So for example, there are more structured approaches to tagging the data points themselves. I encourage you to go in the literature and take a look. After this phase, so supposing you have the core categories, you are in the phase of selective coding. Selective coding means you take your core categories and you compare them, trying to make sure that they don't mean the same thing or that they don't have any overlaps. This process is called theoretical core saturation, densified categories. Those are the ones that are coming out after this process of selective coding. So essentially you are taking the categories, you're comparing them internally, you are essentially evaluating the extent to which they are sufficiently decoupled. You can think of it this way. The last exercise is for you to come up with what phenomenon does your exercise explain. Is that phenomenon, is the theoretical coding, or rather, is the theoretical framework that you have come up with, this categorization iterative exercise, is this theoretical framework what you were supposed to explain? Is it the answer to the question that you actually had? This is called theoretical coding, because it involves the usage of all sorts of additional exercises for example, content analysis, or cross-referencing, or further memoing, or further sorting, or even chronological analysis. So time-resolved analysis, so a reiteration of the analysis, which is time-resolved, to come up with what is known as the theoretical model. So the model which actually explains what it provides data on what you, the analyst, were supposed to come up with in the first place. Okay, so let's do this in action. Let's do an example. Open coding. I have, in my context, is a paper, go figure. In this paper, we were trying to figure out the causes. So the causes for specific problems in the process of coming up with a decent software architecture. Coming up with a decent software architecture is an extensive process. It involves a lot of stakeholders. So these are software developers discussing coordination dynamics and problems. This is a focus group, remember, very important. So it's a series of people that are discussing. And this is a piece of text that I reported from their conversation. The user reviews the story, keeps the distance from requirements, blah, blah, blah. This is a piece of text. The content of the text is not relevant for this example, right? So imagine it's a piece of text. Labeling the phenomenon means installing labels. So I'm looking for problems, for example. Problems being described with architecture and requirements constructs. This is my label, single point of elicitation. SPE is my mnemonic, is my label. So I'm applying that label to this piece of text right here. So can you see my cursor? Can you see the cursor, Alex? I think you can, right? Let me see. Yes, okay, good boy. So this is my label, SPE. Concentrate more on the functional. This is probably an imbalance in requirements quality, right? So this is another label. Now, if I keep doing this exercise, this labeling, to the rest of the texts that I will have, I will come up with my open coding. Now let's do more stuff. Let's actually focus on the open coding. Let's see how to apply the code itself. What I did is use virtual post-its on the PDF. I use PDF aggregators and then comments on the pieces of text. It's very easy, very straightforward, very simple process. So you apply these codes over and over again, and then you want to discover the categories. So for example, you have one category which is elicitation problems. In this case, the code that we had, which was, what was it? Properties and dimensions. Then you have individuals problems, so people capturing user stories. That's another category. This is my analysis, my interpretation, right? So I still need to confirm this. Let's move forward. You elaborate further on these categories. Let's take individual problems and elicitation problems. I relate these two. I know I have found instances to these two. Can I do more on that? Yes, I can. I can find further codes that describe these categories. So for example, communication has evidence of different levels of formality. Different people will speaking with different registries. This is a property of the individual's problems. Then there's description formality in the requirements side. That's a characteristic of the elicitation angle. Let's do one more. We can do content analysis because, for example, communication formality was discovered 34 times. I applied this code 34 times. And same goes for requirements description formality. So that's even graver than communication formality. And then you have memos. What are memos? Memos are or reflect tips and tricks that you find in the categorization schema. So for example, there is a relation between these two. I have found these relations in 20 memos. These 20 memos say there is a relation between communication formality and description formality from a requirements to individuals perspective. This relation is recurrent. So that means is relevant, is very relevant. And at the end of this exercise, the further you look at the data iteratively as part of this exercise, you will also presumably come up with categories that will amount to standardized frameworks for categories. Now, this framework, the 6C model for grounded theory, is a framework which is standard. So in principle, to explain a phenomenon, you are supposed to capture categories which belong to these 6 classes: context, condition, contingency, consequence, cause, and covariance. This is your category right here. Now, there are probably different categories around it that will describe the context, the condition, the consequence, the contingency, the cause, covariance. I encourage you to go and take a look at these again, because this exercise is exactly what will eventually lead you to come up with a theoretical model that explains something, that does something in action. Okay, let's move forward. Let's take a look at the categories themselves. You have cause, obviously, so events and circumstances that give rise to specific consequence. You have conditions, which are constellations of variables around it. Context, so circumstances around which specific context has manifested. You have covariances, so things that mutually vary. So they have a relation in between and they have a cause and effect trade-off being enacted. So they are related somehow with a cause-effect relation or evidence. A contingent is what you are actually trying to measure, the value that you are manifesting, or what you are trying to reduce or improve or optimize, right? So what really brings about benefit, what is the variables, for example, cost or cash flow or dollar signs. Those are contingencies that you want to take a look at. Here's an example. Now, this is a very good example from my former PhD advisor, whom Alexander, I think, knows, Hans van Vliet. This is published in a journal by the name of Information and Software Technology. It's a very good journal. This explains what happens when you adopt agile methods at the level of enterprise computing. So, crosswise to an entire organization. Is a grounded theory which uses interviews, it uses focus groups. It's actually quite well-structured study, and I know because I helped design it. So this is a very good example. You have, for example, the context is agile teams in a traditional enterprise. You have causes for specific problems. A category is the increased IT landscape complexity, so the increased in software architecture landscape complexity. And you have consequences, contingents. Now keep in mind, not always will you find with the data that you have all of these categories. You will not necessarily find them and address them always, but you will be required to address them at least partially and explain to me, the reviewer, why you have not addressed or why you have not found specific constructs that belong to any one category, because that is a finding as well. The fact that you do not have data to explain causes, for example, or that you do not have knowledge over the consequences of a specific phenomenon means that either your sample is wrong, there's something missing in your research design. So go figure. Doing this exercise also make sure that you have some sanity in your research design. This is especially true when you have a constructivist approach in which you are also changing the research design at runtime. And this is it. Keep in mind, your grounded theory is essentially either the concatenation of different 6C models, because you might have different phenomena captured in the same domain, in the same study. You might have different phenomena which are related to each other. How do you find the relations? Is by using memos, is by using this continuous exercise. Now, my general recommendation to you, it is very difficult to apply grounded theory systematically in a defensible and structured fashion from start at the very beginning without guidance. So my hint to you is find someone who has done it and failed, like me, multiple times, and learned the hard way, and make sure you get that someone to help you. And I can help. I'm committed to help. I'm a big fan of students. I work for you, as a matter of fact. I'm a big fan of Alex as well. We do a lot of stuff together. So reach out to me, to Alex, to whomever, but find someone, plug yourself to someone who knows how to run grounded theory if you really want to do grounded theory. As a matter of fact, qualitative research is much more difficult and more expensive, but it also is very much more rewarding, I would say. Nan Young has a question. Yes, Nan, go ahead. I'm overblowing the time. Yes, I know, but yeah, probably I'm overblowing. Am I overblowing the time? I think we had that 15 minutes, so it's fine still, right? I think we have 15 minutes more, right? Let's see if there's a question. Let's see. Is there a question? I think Nathan has a question. No, Nan has a question. Go ahead, Nan. We won't hold it up against you. There's no stupid question. Questions are our friends, always. Questions are good for you. Questions are like sugar in your coffee. And I'm not endorsing the usage of sugar in coffee. I'm an Italian half, so you shouldn't use sugar in your coffee. Okay, whoa, that's a big question. Do we need to choose data collection analysis approach differently? We have different roles in the study. Let me read this slowly. Okay, now you can read this. Okay, so do we need to choose data collection analysis approaches differently when we have different roles in the study? Different roles meaning different people? The answer is yes. Yes. Depending on the different roles, these roles will have most likely different registries. By registries, I mean they will give you data in different formats. Even if you use interviews, you will have different registries of talk, of discussion, different levels of abstraction, which means it will most likely require different analysis approaches. The answer is yes. Next question. I guess in most of cases, the researcher observer is not supposed to intervene. Yes, that's right. What if the researchers are part of the study, collaborating with developers to solve a real problem? That's ethnography. So right there, there's an ethnographical, ethno-methodological question you have there, Nan. Or action research. Action research and ethno-methodological are slightly different, because in action research, you are working on the solution and then you bring it to the evaluators. You do not interact with the evaluators. You just capture the behavior, the reaction of the evaluators with the solution. In ethnography, you are yourself embedded in the construction of the solution with the evaluators. The evaluators are helping you in figuring it out. You are part of the endeavor. You're not doing back and forth. You are part of it. So what is your question? Which data collection analysis approach should one follow? Oh, that's a good question. I would say it depends on what you want to evaluate. If you want to evaluate the validity of the solution, then you are doing an an ethnographical research to evaluate the validity of the construct. There's actually a mistake in that design right there, because if you are evaluating the value of the construct, then you shouldn't be part of the construction of the construct. So if you're part of evaluating the goodness of a specific product, you shouldn't participate in the construction of the product. In principle, this is true in principle. However, if for whatever reason you are part of that construction, this is typical for a thesis, for example, then what you want to do is structure the ethnographical research in such a way that you do the evaluation incrementally. So you capture all evidence that reflects the validity of that construct being constructed. This can also be metrics. If it's a software product, then you want to keep track of software quality metrics all along the construction. So you can also aid yourself with all sorts of quantitative devices, and you can come up with trends over time. The point is, in such a specific situation, I would use a quantitative approach with software quality metrics, for example, and the capturing of maybe assessment forms that you can feed to your practitioner friends, and they can tell you how the construction process is going, right? It's like a review of their own work. Because during review of their own work, they will conduct what is known as self-ethnography. Self-ethnography, there you go. Self-ethnography. Now, self-ethnography also comprises components of self-criticism, self-reflection. Now, people who are engaged in making an endeavor successful, they will do these exercises correctly. So doing this, so to answer your second question, boy, this was quite a question. It was a good question, by the way. You might, for example, use self-ethnography, self-reflection, for example, but accompany it with quantitative angles is always helpful. I hope that answers your question. There's a bunch of questions here. Okay, I can imagine researchers might be inevitably. What additional methods can? Okay, so I answered that question. I think. Did I answer all questions, man? Oh, did I answer all the questions? We're almost done. Don't worry. There's like 10 slides left. Don't worry. It's fine. Yes, thank you. Yeah, I win. Yes. Okay, so recapping, summarizing, grounded theory. Oh, if there's more questions, just fire away. We're big fans of questions. I'm a big fan. A researcher. We eat questions for breakfast. Okay, you drop out, Alex. You know I'm a big fan, but I'm having fun here, so you should go. Oh, don't worry, it's my pleasure. And I will have, as a matter of fact, I will have to drop out as well at some point, unfortunately. But I like you guys more than boring department meetings. Okay, so in summary, this is a whole process. I tried to recap it right here. Just go through and take a look. This is just a quick recap. So take a look. As a example, I do not have time to show the example as well more practically, but I'm leaving you sources that you can go and take a look yourselves. So in this case, it's commit notes, which have been analyzed with grounded theory. There's an open source file, which you find there. There's a partially coded file. There's a list of codes with the explanations. Obviously, the codes themselves need rigorous definitions. So go and take a look. I will live the example for you. Again, I think I stressed this already, intercoded reliability. There's all sorts of approaches to do it. I stress that all of the coding exercises that are part of grounded theory need necessarily at least more than one observer. Okay, Arngrimmer. How am I pronouncing your name correctly? Arngrimmer. Arngrimmer. Where are you from, Arngrimmer? Arngrimmer. I think you're from Iceland. Yes, a big fan. Yes, massive Vikings. I love them. Okay, so how is theoretical saturation measured? It seems like a hard thing to evaluate. Yes, it is very hard. You're very right. So first of all, theoretical saturation is a principle. So you yourself need to define for your own study, what does it mean to have achieved theoretical saturation? In general, it means that if you have one more, for example, interview, this interview will not reveal information that you have already witnessed in previous interviews. This is theoretical saturation during data gathering. If it's a theoretical saturation during grounded theory, for example, it means that you cannot, there is no way in which you can categorize your labels, your codes further. There is no superior level, higher, more abstract concept that you can create. There are no superclasses left for you to create. That's theoretical saturation at data analysis level. Does that make sense? In principle, you are supposed to cast theoretical saturation for each of these phases, right? So data gathering and data analysis phases. Does that make sense? Does that answer the question? Maybe it does, maybe it doesn't. Yay! Good boy. And by the way, you have it recorded, so you can go back and check it out. All right, so yeah, intercoded reliability. We have already established this. I've already made an example. I think you are very much familiar with evaluations of agreement. There's obviously also quantitative approaches that you can use. So CONCAPA, you know these already. I will not spend too much time. Know that there is a package in R, which is IRR, that also signifies that you can partially automate this exercise. Now, keep in mind, the interclass correlation coefficient is not a bulletproof solution. You are supposed to defend the extent to which ICC reflects the validity of your study. It can be strong, can be almost perfect. If it's beyond 0.4 and 0.6, there's nothing wrong with it. If it's below 0.4, then there is something wrong with it. That's the point. That's how you should use it. It's not only to claim validity and partial generalizability of your study, it is also to understand whether or not your research design actually makes sense. So keep this in mind when you compute ICC. Yeah, there's examples on how to do it, and this is Krippendorf alpha. I don't want to spend time on this. I know you have done it, so I will not take your time on this. In summary, you have lots of kinds of quantitative data. You have lots of kinds of scientific inquiries that reflect qualitative design. We have looked at grounded theory. Grounded theory is only an analysis method, which, however, reflects a prior research design, which has specific other aspects to it, which you need to balance out. There's all sorts of variables out there that you need to be able to think about and anticipate. However, you also want to structure your study in such a way that every data type amounts to a specific data analysis that will give you the answers that you're looking for. And in terms of concluding remarks, quantitative and qualitative, they're not mutually exclusive. They should go hand in hand. I think we have said this already. They interplay often, even unbeknownst to you. Even if you don't do it, at some point they will interplay. You will encounter recurrences. You will encounter numbers in your exercise, in your scientific endeavor. So you can either be prepared to improvise, or you can envision it in your research design and try to think about it, try to use it to your advantage. And then last but not least, planning qualitative research for quantitative studies and the other way around is also extremely different. So that is also why you need to decide upfront what are the research goals, the research objectives that is paramount. You start from your research problem specification, which can itself require a pilot study. In fact, it does in a lot of data scientific endeavors. A pilot study can, for example, lead you to a well-formed formalization of the problem, as, for example, a graph theoretical approach, or what have you. And the research design will need to cater for those objectives, those research questions and assumptions, and so on. And with that, I conclude. I think I took a lot of your time. But I think it was, I hope at least it was well spent. Maybe we have still some time for a few questions. Questions? Any more questions, thoughts, doubts, curiosities, remarks, issues, clarification desires? Nathan and Dragos are writing. Dragos, I know you. I know you. You might have questions as well. No problem, Nathan. My pleasure. Dragos is typing. Okay, Dragos. Oh, Dragos. Oh, let's see the question. Give me a question. Fire a question, Dragos. Give me a best shot. Taking too much time, Dragos. You are taking people's time off from break. Come on, man. You're better than this. No, don't worry. I'm kidding. I don't want to put you on the spot right here. By the way, as part of your study, you might be interested in using grounded theory. because so Dragos is conducting a nice study on no-ops. No-ops is a variation of DevOps, which I'm not going to tell you what it does, because Dragos will tell you at some point, because it's going to be the end result of his research. And as a matter of fact, he's gathering a lot of qualitative evidence as well. How do you measure intercoder reliability in case of open coding? Well, that's reasonably simple conceptually. So you have your text, and I have you applying codes. So Dragos has applied codes, and then I go in the same text and I apply different codes. So we measure the extent to which this code application exercise agrees, or whether or not I agree with you applying a specific code. So, for example, you have coded a piece of text with no ops. I say no. It's not no ops. It's so far your application of code is so. So this is disagreement, right? So we measure the entire disagreement in terms of all of the codes that you have applied, and you come up with a Krippendorff alpha measurement, or Cohen kappa. Cohen kappa is slightly better because it's more difficult to compute, but it also accounts for incidental agreement. I'm not sure whether you have had some introduction to this as well, which I presume you have, but Cohen kappa is much better than Krippendorff alpha, because Cohen measures incidental agreement. So it's good. It's good stuff. Does that answer your question, Dragos? Yay! More questions. Anyone? Let me see. There's no more questions. Okay, going once, going twice. All right. Then it seems like there's no further questions. Of course, you have my email, so let me know whether or not you want to follow up. And I see Valentina is there. Ciao, Lindy. Ciao, Lindy. Right. So I presume, Nathan, do we need to stop the recording right here, right?
Yeah, I'll stop the recording.
Okay, so you go ahead and do that.